present value because you're taking money out of a bank. Regarding how to solve questions with annuity on the calculator, so how would you actually figure out that it's annuity? It doesn't clearly say here. So Tracy's saving up to put a deposit on the flat. This is one key thing. Usually compound interest is for investments or loans, but this is saving up. So the idea is that she's going to put 200 euros every month. So that's one key thing in annuity is that you're putting a constant same amount on a fixed period. So for every month for 5 years, and the interest is 2.5 compounded annually. This is key here. So calculate how much she has saved at the end of 5 years. So for annuity, you immediately need to put these as 1. You then figure out, well, she has a present value. She has an amount she pays every month, and that is 200. And just point out to yourself that you're talking about month here, and I'm going to explain why in another question. But we're dealing with months here in terms of payment. So when she has the months here, she then needs to, we need to know how much she saved at the end of 5 years. So we're looking at a future value. Remember in the first video, I explained that you need to use a pair, either the present value or PMT and the future value. In this case, we need the future value, or we're just using the future value. So the present value is just going to be 0. Next, what's really important is the number of years and the interest. So the idea is the interest is 2.5 compounded annually, but the payment is done in a month. So you need to take this compounded annually and divide it by 12. That's why the month is important, because it's 2.5 for the whole year, but the payment is done per month. So you need to split it within each month. And then the payment is done in 200 per month. So the N now, unlike the compound interest, this is not exactly the years. This is how often the payments are made. So it's not 5 years, it's 5 times 12 years. Because again, the key is that the PMT is in months. So we'll put that in our calculator. We have 5 into 12. We have 2.5 divided by 12. We don't have a present value. We have the PMT as 200. Again, you can do a negative 200 here because they're taking an amount out of the bank. I explained this in the compound interest video, that because you're taking an amount out of your account, it's going to be a negative 2, and you put a negative number. This is going to stay as 1. And what we're trying to calculate is the future value. So we go alpha and then enter, and we get 12,768.11. So it will be 12,000, and that's going to be euros. So then the flat she wants to buy costs 240,000, and she has to put a deposit of 5,000. Work out if she saved enough. So you need to work out the deposit 5,000. 5% of 240,000, and that's just going to be 5 over 100 times your amount, and it's just simply 120,000. And your answer would be yes, she saved enough. I'm just going to shorten my answer, but you can say it's enough because she already would save 12,700 to above the required amount, so she would have saved enough. Now, why am I focusing on the monthly? So it's these two steps that are a bit tricky, the N and the I, because the annuity, so when are you paying or how often are you paying, will determine how you calculate the N and the I. So as a contrast, we have this question. So she has been left an annuity of 25,000 in a will. So she's starting with this amount. The annuity is for 10 years at 6% per annum to be paid out annually. Work out the amount that student receives each year. So these stay the same as we mentioned. We have an annuity, so this is in the present. It's not an amount they're aiming for, it's an amount they have already. So we have the present value, and we're dealing with annuity to be paid out annually. So it's a regular payment annually. This is not compound interest. This is an annual payment. So you're looking at PMT, which means the future value is just going to be zero because we're not going to need it. So the work out the amount she receives each year. So we don't know what it is, but what we know, important information, is that we're dealing with an annuity per year. We know this is 25,000. The interest is per per annum, 6% per annum. I don't need to divide by anything because my interest is described per year and my PMT is also by per year. So you need to make sure the units all match up. So the units of your PMT match up with these two. And the annuity is for 10 years. Again, because the payment is done per year, so we're talking about 10 payments and we don't need to multiply by 12. So this is what I mean by the units. You have to be careful with the units here. So if we do the calculation, we have 10, our interest is 6, our present value is 25,000. We don't need the future value. And then the PMT, you'll notice that it's going to be negative, but we're just going to take the positive answer. So this is going to be 3,396.70. So you always take the positive answer. Remember, if you're dealing with PV, PMT, FV, because you're using two of those three, one of them will end up being negative. It just describes how the money flows, and nothing too intricate. So we have this for this amount. Now, what if something else was missing in annuity? Again, it's easy to use the finance solver. So we have this question. Colby borrows 2,500 to buy a scooter. The bank charges 3.4 per annum interest compounded monthly. So far, it doesn't seem like it's annuity, but then it says Copy has agreed to pay off the loan in 3 years, and then the key thing is how much he has to pay back each month. So we have a fixed payment that he has to give each month, and an initial amount he starts with. So again, we're dealing with annuity. This will be 1. He borrows 2,500, so we have a present value. We're looking for a PMT, which means our future value will be 0. He needs to pay back each month. We don't know what it is. So, but we know we're dealing with a month. That's our unit. The present value is 2,500. The interest is 3.4 per annum, compounded monthly. So it's 3.4 per the whole year, but you need to divide it by 12 because we're dealing with months here. And then for the year, it's 3 years, but he's going to be, it's not, remember, in annuity, the end doesn't necessarily represent the year, it represents how many payments are being made. So it's 3 years, but he's paying each month. So 3 times 12 payments. So these are the values, and we go to our calculator all the way up, 3 times 12. We have the interest as 3.4 divided by 12. We have 2,500 as the borrowing. Everything else stays the same. Alpha solve, and we get 73.14. Yes, it's negative, but remember, we don't need to deal with the negative. So 73.14 each month, he has to pay that with that interest, and in 3 years, he's going to be able to pay off the 2,500. So just to be aware of these. Again, negatives here won't really affect much. In annuity, you don't need to worry about the whole compounded monthly. It will make a difference if it says 3.4 per month. If it's set per month, we just keep it as 3.4 because the rate is per month. But the 3.4 is per annum. and the interest is compounded monthly because he's paying back monthly. So because the 3.4 is described as a yearly interest, we have to divide it by 12. Hopefully the videos were clear regarding annuity and compound interest, and how to use the finance to solve these. Uh, the compound interest is straightforward with the formula. The annuity is a bit tricky, just making sure that your units remain the same, whether you're dealing with month or year.